All right, I'm going to switch around a little bit. I just looked and we have 92 days left on the calendar before the end of the school year. Okay, so that's the difference. We have 92 days. In other words, that includes weekends. And according to our daily ticker, I took one off for today, we have 66 days left of school. So what I want to do is I'm going to make up a math problem, having fun with the number 66, knowing we have 66 days of actual school and we have 92 days in the calendar. So my question is going to be, how many days of school do we have? What percent of them are school days and not weekends? So I make up my fraction. We have a gardener out there. I hope that's not too loud. But if I want to find out what percent of the 92 days that we have left of our calendar year, how many of them are school days? Well, I'm going to make a fraction, 92 being the total number of days in the calendar, and the numerator are just the number of days that are school days. And because I made it a fraction, that means I can divide the bottom into the top, or in other words, come up with a percent. And so let's do it. Let's take 66 divided by, because when we read a fraction, we read it from top to bottom, 66 divided by 92. Now I know that percent means out of 100, so I have to cut this number up into 100 equal pieces. And I do that by adding my decimal point, which is the indicator between the whole numbers and the partial numbers. And then I put 2 place values after it because the first place value is cutting it up into 10 equal pieces and the second one is cutting it up into 100 equal pieces, just like we did for our calendar 100th day party. All right, now we're ready to start doing the fun. Let's estimate how many times does 92 go into 6? Well, I know it doesn't go in at all. How many times does 92 go into 66? Once again. By the way, if it did go in one time, that would mean it's over 100%. We'll get into that a little bit later. We'll do something fun for that another day. And now how many times does 92 go into 660? Well, I'm going to round this up to, you know what I do? I'll give you 9. Because the 2 is close, watch how I'm going to front end estimate and see if you can't follow along. I know that 92, this is so close to rounding down to 90. So what I do in my head is, what can I multiply together by 9 that's just going to give me this? Does that make sense? And I know 9 times 8 is 72. 9 times 7 is 63. So that's kind of the way I'm going to do it. Remember, let me show you this. I show this all the time. I'm trying to do it different ways. Everybody does it a little bit different way of estimating. I want you all to estimate to get a ballpark for how you're going to do this, so you don't list 92 times 1, 3, 4, 5, 6, 7, 8, 9, and spend all your time multiplying them to fit in. You need to really estimate to get in the ballpark so you're not spending so much time. But the way you estimate, whether it's front-end estimating or rounding, whatever way works for you. But I know that 9 goes in, see, I'm just ignoring this place value and this place value. And I'm doing that because it's so close to 0. Now, if it'd be close to 5, well, then I would round this up naturally. But I'm just getting rid of this place value, one full place value, and I'm getting rid of this place value because this is the place value I'm dividing. And now I'm just asking myself, how many times does 9 go into 66? By doing this, it's a little bit more accurate than if I were to round up or down in most instances. Okay, because if I would, well, we'll get into it. So how many times did I say? Well, 9 times 7 is 63. So that's going to be, I know it's going to fit in. So let's see. 14, 63, 64. See how neat that worked out? I didn't even need to do any work over here. It's all about efficiency in math and understanding multiples and front-end estimating, all that fun stuff. Okay, so let's this, we have 6 and we have 1. Bring down this place value. And I'm going to do the same thing. I'm just going to look at this 9. What's 9 times 2? 18. That's too big. So I know it's just going to be 1 time. And for our intents and purposes, we're not going to be finding a remainder. But we do know now, look, we have 66 days left of school, and we know that it is 71% of the days are school days until the last day of school. And by knowing that, what percent of those days are weekends? Well, if 71%, because I've converted that 71 hundredths to 71%, because both percent and hundredths mean out of 100, if 71% of the days of these 92 days are school days, what percent of these are not school days? Well, since we cut it up into 100 pieces, we can subtract this from 100. So I know that it's going to be 29%, because 29 plus 71 is 100. So if 71 represents the days of 92 days that are school days, then that means that 29% is the percent that are weekends. I hope you're able to follow along. I know it's a lot, but we've been doing this for a while, and so I like to add something each time to expand your mathematical horizons.